All right, let's pull back the curtain and talk about the tools that data engineers are using every single day. We're going to take a tour of what I like to call the modern data factory and look at the 10 core tools that make it all run. Let's get into it. So, just for a second, think about the last time you bought something online. You find what you want, you hit that buy button, and poof, a confirmation email lands in your inbox. But what really happens behind the scenes? Where does that click go?
Well, that one little click sends your order on this incredible journey through what is essentially a high-tech data factory. And in this factory, data is the raw material, and business insights, well, that's the finished product. Today, you and I are going to take a full tour.
So here's our game plan. We'll start at the loading dock where the data first arrives. Then we'll check out the main assembly line. After that, we'll meet the factory manager, look at the very foundation of the building, and then wrap up with a complete map of the whole operation. Let's get started.
Okay, first stop is the factory's loading dock. This is where all the raw materials, we're talking every click, every order, every single user interaction, come flooding into our system. It is a constant, massive flow of information. And the first machine you'd see here is Apache Kafka. The best way to think about Kafka is as this super fast, industrial-strength conveyor belt. Its one job is to catch every single piece of data the second it's created and move it safely into the factory to get processed. And this is basically how it works. You have a producer, that's the thing putting your order onto the conveyor belt. The belt itself is called a topic, and then you have a consumer at the other end, instantly picking that order right off the belt. Simple as that. So all this data is flying in on the conveyor belt, but where does it all go? It can't just pile up on the floor, right? It goes into the central warehouse. And tools like Snowflake and BigQuery are these unbelievably huge cloud-based warehouses built to store just massive amounts of data in a really organized way.
Now here's where it gets really interesting. Once all that data is neatly stacked on the shelves in our warehouse, we can start to ask it questions. Using simple tools, we can basically walk up to the warehouse manager and say, "Hey, can you pull the records and show me the total amount each customer has spent?" This is really the first step to creating actual business value.
Okay, our data's in the warehouse. Now let's head over to the main assembly line. This is where we take all that raw data and we clean it, reshape it, combine it, and basically transform it into something way more useful.
The biggest, loudest machine on this factory floor is, without a doubt, Apache Spark. This is the heavy-duty engine. You know, when you have a mountain of data so big that one computer would just choke on it, Spark is what you use. It splits the work across a whole fleet of machines and gets the job done at incredible speeds.
And this is what Spark does so well. It takes a huge job, like counting every single order from every single customer, and it breaks it into a bunch of smaller, manageable chunks. Different machines work on those chunks all at the same time, and then Spark puts the answer back together. It's really powerful.
But you know, not every job needs that massive engine. Sometimes you need to do some detailed, precision work. And for that, you've got Pandas. Think of Pandas as the local workbench where a data scientist can dig into a smaller chunk of data, clean it up, and really explore it right on their own laptop.
So, at the end of the day, here's the key difference. It's all about scale. Spark is for the whole factory's massive output. Pandas is for the detailed work you do at your personal workbench. Both are totally essential, just for different sized jobs. And that focus on detail leads us right to our next tool.
So next up is dbt, which stands for Data Build Tool. Now, if Spark is our heavy engine, then dbt is like a set of precision engineering tools. It doesn't actually move data around. It works on the data that's already in our warehouse, transforming it into clean, reliable, and importantly tested models, all with pretty simple SQL. And this is exactly what dbt does best. It takes that messy, raw data and, using a set of instructions that you can use over and over again, it builds these clean, reliable data models. It's all about creating a well-documented assembly line to make sure every transformation is consistent and high quality.
Okay, so we have all these powerful machines, right? But who tells them when to turn on, what to do, and in what order? And maybe most importantly, who's checking the quality of the final product? It's time to meet the management team.
So meet Apache Airflow. This is the factory's conductor. Airflow holds the master plan. It's basically a map of all the jobs that need to get done and, crucially, the order they need to run in. It makes sure the conveyor belt starts before the assembly line and the whole thing just runs like a well-oiled machine. It orchestrates the entire symphony.
And this is a perfect, super simple example. We've got two tasks. One to extract data
and another to load it. You see those two little arrows in the code? That is the critical instruction to our conductor. It says, Task 1 must finish successfully before you even think about starting Task 2. That's orchestration in a nutshell. And of course, at the end of any good assembly line, you need a quality inspector. In our factory, that's Great Expectations. Its entire job is to run automated checks on the data to make sure it meets, well, our expectations. Is this column always filled out? Is every order ID unique? It catches those little errors before they turn into big problems.
So, before we finish up our tour, we've got to take a quick look at the factory's foundation. I mean, all these tools are amazing, but what are they actually built on top of?
Okay, real quick. First, you have GitHub. Think of that as the factory's blueprint room, where all the code and plans are stored. Then you have Docker. Docker basically puts each tool into its own standardized shipping container, which means it will run the exact same way no matter where you put it. And finally, you have Kubernetes, which is like the master logistics system for the entire factory, managing thousands of these Docker containers and scaling everything up or down when needed.
And that actually brings us to the end of our tour. We've seen how all these individual tools and processes don't just work alone, but they come together to form this one, cohesive, and incredibly powerful system.
So here it is, the complete map of our modern data factory. You've got Kafka as the conveyor belt, Snowflake as the warehouse, Spark and dbt working on the assembly line, and Airflow conducting the whole show. Each tool has a really clear and vital job in this whole process of turning raw data into something useful.
Now, this toolkit is pretty much the state of the art today, but the world of data is always changing. So the final question I want to leave you with is this. As data gets even bigger, even faster, even more complex, what's the next great tool for our factory going to look like, and what new job will it do? That's a question for the next generation of builders.